Bismillah ar-Rahman ar-Rahim. Today we're going to solve OCW number 2, and we're going to show you the equation for the law of sines and law of cosine. Well, if there is a triangle and you have the angle, look at small a, small b, and small c, the angles. Or let me just do this in a Word file. Like if you have the angle like this, triangle with an angle A, angle B, and angle C, and you have the length A of the triangle, length B, and length C, and you want to find out one of the lengths, or if you want to find out one of the angles or one of the other lengths. So either you use the law of sines, as you mentioned before, the length A over the sine small a. So this is length A over sine A. Length B over sine small b. Length B over sine small b. Or length C over small sine, sine of a small angle C. So this is the law of sines or sine law. Now cosine law, according to physics, it's different. If you want to find out one of the lengths, let's say if you want to find out length C. So it's going to be written as the by law, C square equal, what is the other length? A square plus B square. And then you have to do a minus 2. Length A times length B times, now, since we are doing between A and B, because you are doing it between A and B, so that's going to be the angle C. This is between A and B. So that's going to be minus 2AB cosine C. And you could do the rest. If you want to do the other equation, A square is equal B square plus C square minus 2BC cosine. What is between B and C? If you could look at between B and C is the small a, cosine A, and if you want to find out the other length, B square, and that's A square plus C square minus 2AC cosine. What is between A and C? And that is a small angle B, cosine B. So this is the law of cosine. So we have two laws, cosine law and sine of law. Whatever we have unknowns, you could just apply any of these laws. Let's look at our problem then. OCW2. Well, now we're going to solve it with two methods. The first method is by applying the normal x-axis, and let's see that this is the y-axis. I'm going to assume that this is the y, and this is the x, positive x, positive y. And he needs to find out the magnitude of the resultant force. He wants to find out Fr. So let's do F1. Let's find the vector F1. This is going to be in the negative x, F1. So minus F1 is 13 minus 13 cosine 60i. And then minus 13 sine 60j. And that is kilonewton. F2, this is going to be positive x. F2 is 15. So 15 cosine 45i. And the other one, F2, is the negative j minus 15 sine 45j, and that is kilonewton. Now we should add up the forces, but only add up the i's together and the j's together. So the resultant force in Cartesian format, minus 13 cosine 60, that's minus 6.5, plus 15 cosine 45. Let me just do the calculation. 10.61. Then you add it up together. This is 4.11i. And then minus 13 sine 60, that's minus 11.26. 15 sine 45, that is minus 10.61. When you add them together, it will be minus 21.87. It is not good to make it three significant figures right now. You do it at the end, the final answer. This is in kilonewton. Now you could find out the magnitude of this force, the square root 4.11 square plus 21.87 square, and that will give you 22.3 kilonewton. Okay, that's the answer here you're going to put for this problem, but let's solve it using the parallelogram. This is another alternative solution. That if he asks you, because in this example he said that use the parallelogram law. Okay, so we're going to use that law. We're going to put the first force, which is the force 1, and that is, what's the force 1? 13 kilonewton. That's 13 kilonewton. And I'm going to put the other force 2, in the head. The tail of force 2 is in the head of force 1. What's force 2? 15, so it's bigger, little bit bigger. That is 15 kilonewton. I'm going to put the tail of the second force on the head of the first force. Okay, and then that's going to be the resultant. So the resultant will be from the head of the second force to the tail of the first force. This is the force resultant. Okay, now he needs to find out the force resultant. But let's look at the angles. What are the angles? Let's look at, this is the line. This is the x-axis. Okay. Okay, so the axis here, you can see that this force, F1, has an angle, you can see it from here, 60 degrees with the x-axis, which means force 1 has 60 degrees with the x-axis. Force 1, which is 13, has 60 degrees with the x-axis. Okay, so this is 60 degrees. Now, the force number 2. The force number 2, you could see it here. It has 45 degrees with the x-axis. Force 2 has 45 degrees with the x-axis. So I'm going to put 45 degrees, even though this is not within scale, but that's okay. Which means that the combined angle 60 and 45, it's 105 degrees. So I'm going to erase this. And I'm going to put the angle, total angle between these two forces, 105 degrees. Okay, now can I use the law of sines? No, I need to find the other angles, but I don't have the other angles. So I should use now the law of cosines, because this is, sometimes you are stuck with one law. You cannot use both. So here I'm going to use the law of cosines. So I'm going to find out this length. So this is FR square is equal, the other length, 15 square plus 13 square minus 2, 15 times 13, and then it's cosine law, so it's cosine. What is the angle between the 15 and the 13? 105. So this would give you, let's do it calculator, 494.9. Okay, so now you find out the FR, which is the square root of 494.9. That will give you, okay, 22.3 kilonewton. And that is the same answer we have before. Okay, so using law of cosines, you could find out the same answers. Using the regular cosine and sine and summing up all the i's and summing up all the j's, you could find the same answer. I wish that this could be understood, inshallah. Thank you.